OpenMV journey with RT thread RTOS on Renesas RA8 vision board. So, Jamie.
Hello, Max. Thank you. How are you?
I'm very good. Am I pronouncing Jamie right, or?
Yes, okay, it's right. It's right.
Okay, good.
Okay, so you can see my presentation?
I'm not sure. I can see a window that has a black half and a white half.
Oh, okay. Wait a second. We present again.
Okay. Yes. Almost. No, it's black again.
Okay. Is the start is okay?
No, just seeing a black window.
Okay, wait a minute, sorry.
If you've got multiple screens, you might be sharing the wrong one.
Yeah. No.
So we can see the slides on the left.
Okay, sorry, wait. I know what is the problem. It's here. Share the screen. This is. Please tell me that you can see my slides now.
No, not yet.
Oh, God. So we don't load. Sorry, wait me a second. Okay.
Do you have multiple screens?
Yeah, because I use a Mac, so I have a lot of screen right now.
Okay, because if you.
Yeah, but it's because I think so. This because I using the PowerPoint and
sometimes when you use the PowerPoint, if it gives you two windows,
yes,
you can go into you can swap the screens over in the PowerPoint.
Yes. So okay, wait. I start again to share my screen.
Yeah, there's one window that says display settings and you can swap things over.
So now you can see my slides.
Yes, but
yes?
again,
okay.
again, I'm not seeing it in presentation mode. I'm seeing it in.
Not in the presentation mode. Oh my God. What's happening here? I hate that. So now?
Yes.
Yes.
Ta-da!
Okay.
Yes. Awesome.
Finally. Thank you. Okay. So first of all, thank you to RT3 for inviting me to this talk. This is my, I think so. This is my second. This is my second way to assist in this talk. The last year I was here only to attend it. So now I want to present my two projects that right now I'm working on. So this is my agenda. First of all, we make a small introduction about the OpenMV. The next one was my project. This project is finished totally. It's classification or rehabilitation exercise for arthritis patients and as practical aspect. And the last one is the new project that we start using the new board, the new developer kit vision board for RT3. That is controlling a virtual robot using a vision board. So first of all, this is really fast. Explain what is OpenMV. OpenMV is a platform for camera that allow to developer and engineer make a different application in which we need to integrate a computer vision in our project. This platform was designed to be easier to use, efficient, and accessible for the engineers or professionals. The main feature of the OpenMV is first of all, is a programmer camera. This is very interesting because we have a camera that we can program in using, and we can integrate the microcontroller. We have access to this camera, and it's really, really easy and really, really too fast. This OpenMV or this kind of developer kit, we use a MicroPython to programming our application. And as I said before, this is really, really easy to use and to work with this. The main feature is they have a different algorithms to make an application in a vision application, like color detection, face detection, shape recognition, QR, barcode, object tracking, and more algorithms that we can integrate in this kind of developer kit. At the same time, as another developer kit, we can we have a different inspection interface. We can integrate an I2C protocols, UART, ADC, PWM, servo motors, LCD, etc. At the same time, it's compatible with different models, Wi-Fi, Bluetooth, and LCD screen. The most common application is in robotics, automation, security, and education. I think so was most of the useful this development kit. So we start with this. This is my project. This project is totally finished. As I say, this is a classification of an exercise for people that has arthritis. This project was thinking to be used for elderly people. Yeah, because right now, when we go to the doctor of physiotherapy and recommend that some exercise, most of the time this exercise we don't have any other people that say that this exercise is good or not. For this reason, it's really, very important the integration of this kind of technology, because this especially we don't have this especially the 24 hours. Yeah, we don't have especially in our house to control if we have the exercise, we doing the exercise good or not. Yeah, most of the time this exercise is under supervision. For this reason, it's necessary the integration of the new technology, the HI computing, because this technology can help to solve this problem. They're using the deep learning tools and a dedicated embedded system. It's possible to help the people that living alone or the elderly people to control and doing this exercise. This exercise is a very, very important for people that doing a rehabilitation, or people that to try to down the detection or the direction of this the cause of this disease. So I decided to try 4 exercise. The first is the arrow exercise. In the right slide, in the right we can see the different exercise: the arrow, the claw, the table toad, and the fist. These exercises are recommended for hand and wrist rehabilitation. This is the link in which we obtain this exercise. This is the exercise that recommend to make that rehabilitation for people that has arthritis in your hand. So in this project, we are integrating an image processing, deep learning, and a low-cost embedded system. In this deep learning tool, I use an edge impulse tools. I use it to train the model. In a total of 100 images were captured for each class, as a total of 400 images This image was resized for 32 pixels, and the dataset was split in 80% for training and 20% for testing. The hardware that we use this is the new Embed system. This is the R3 Vision board. It's a powerful, really powerful developed kit. We can recognize the object in real time. We can recognize the exercise in a real time. I made this example in another system, and the delay between the classification was very high. But in compare with this developed kit, it's amazing. It's really fast to make the classification. So this is the example of the different image. This taken with the tabletop, the arrow face, cloud, and in this case, the nothing, where the camera not detect any exercise. The first of all, we have the same is imagined in a 2-dimension array, 32 for 32, and then we transform this array for a 1-dimension for 1024 elements. And this is sent into the deep learning model. This image reconstruction is to know if the pixel are when I made the reconstruction of the image, the return the correct way. So to apply the deep learning, I use edge impulse. This is the hyperparameters to train my model. The number of training cycles or the epoch is around 30 epochs. The learning rate is 0.007, and the validation set size is 20%. Integrate a convolutional two-dimensional convolutional network, but inside of I told you I have only 400 image. This is not enough sometimes to train this kind of model. So inside of the model, I use the technical to expand the number of image. Yeah, maybe this try to rotate, to translate, and this we can increase the number of image to train my model. So this is the output of the training process. This is the confusion matrix. And I have around a 93% of accuracy. Obviously, it's important to know that this model, this confusion matrix, is when I have the model in a float weight. The weight is a float. So when I transfer this model to a TF light, we can change this kind of the weight only to int8. For this reason, the accuracy reduced to 88%. So this is my hardware, the development. We have the camera, the LCD screen. I made some modification to the hardware because in the original system, the camera is in the back of the LCD screen. I made a modification to put the camera in front of the LCD screen because the idea is that the person can see your hand and at the same time they can see the classification percentage. Yeah. It says a small conclusion and a future world. This is a low-cost system for classification, rehabilitation exercise for hand. The system allows to determine if the user performed the exercise and accuracy on around an 88%. And as a future world, we try to expand the number of exercise. So this is a small video about how we can use the system. This is okay, so this is the application. So this is the camera, and you can see the different class and the arrow around to 99%. the cloud 84, 91%. The face this is one of the most complicated to classify. Around 60%. So once this is the main idea is try to detect this exercise and make a classification in a real time. So this application can be easy to integrate to the table. We can use a 3D printer to design a small box. We can change using the Wi-Fi communication, which can change the model, because the idea is in the future is if you have your physiotherapy and you have a some exercise, the camera can detect this exercise, but if the physiotherapy say that you need to change or you need to improve the type, the kind of exercise, it's very easier to integrate a new model. Yeah, and the camera start to recognize this new exercise that the people need to do. So the second one, this is the last project that we started maybe 2 or 3 weeks ago. This is controlling a virtual robot using the vision board. In this case, this is I use the Brashio of Arduino. I use a repository for another guy that designed the Brashio in Unity 3D. Just only I use your repository and I use the vision board to communicate the real world with the virtual world and try to move the art using the camera. So I was saying in the first lesson, I talk about the OpenMV. It could be used. It's easier to use and to detect QR, or in this case to detect an IP call. The object of this project is explore the innovation and method to integrate the virtual robot with virtual board, and in the future replace this virtual robot with a real robot. The presentation will be covered a concept to implement, to benefits, to use the vision board and to control the robot. First of all, it's very intuitive to interact, to provide a more natural way to interact with this robot, because we have the real world and we have the virtual board, but the vision board can perceive, but can see the real world using the camera and detect the different markers. And this marker can be sent to this information of the marker. You can send to the virtual robot, and you can control the virtual robot in a safe way. Because sometimes when we are working with this robot, if you calculate the inverse kinematic in a bad way, maybe you can put at different angles. It's possible that the robot move in the wrong way, and we can damage the servo motor, or we can damage the art. For this reason, the first step is use the Unity, the robot in the virtual environment, and connect the real perception using the camera. So we have the first is the IP call. The next one is the camera, the different sensors that we can add to this developed kit. In the vision board, I calculate the inverse kinematic based on the position in the 3D space. When the camera detects this IP call, return the position in X, Y, and Z. And then based on this position in the real world, we can calculate the inverse kinematic to obtain the different angles for each joint. And this angle is sending to the virtual robot or to the real robot. And we can control the movement, we can control the position, and then when we are sure that the calibration of the different transformation matrix or rotation of the position of the hyper call, etc., we can send this angle to the real robot and make the control in the real real life, in the real world. So that's for all. Thank you for your attention, and I don't know if you have a question about this. So
That's great, Jamie. I've posted in the chat saying if anyone's got any questions, now's a real good time to answer them. I am very excited by this gesture recognition. I think there's going to be so many uses for this sort of thing in the not too distant future. If you remember, it's not that long ago that we didn't even think about using voice control for anything until Amazon Alexa and stuff came out. And now in my house, I can say, Alexa, turn on the television. And I didn't do anything to do that. Somehow when you power the television up, Amazon Alexa recognizes that it's there. You can pick the channel, you can search for a program just by speaking. But we communicate very much with our hands. I mean, when I'm doing a video conference with a friend, and he'll say, how about we try this? And I'll go, yes, good one.
yeah, because it's not a verbal communication.
Yeah. So you want that sort of thing, or no, cut it off, no, stop. You want to have that. You want all of. It won't be long, I honestly believe, before all of our appliances, everything in the house, is equipped with speech and sound. It talks to you. You talk to it. It can see you and understand. Again, non-verbal communications. It'll know when you're angry. So you'll walk in the kitchen and the microwave will know that you're not happy. And so it won't say, do you want to hear a joke? No, I don't.
Yeah, it's true, because it could be possible to detect maybe the emotion because many people can interact with your hand, and you can express if you feel happy, you feel angry, if you feel sad. And using this kind of system, it's possible to detect this kind of no verbal way to communicate. Yeah. Of thinking of people that maybe are blind people. Yeah. If you can integrate this system in her house, in their house, you can control many things, because the blind people maybe can say okay, or as you say, put off or turn off the light, or any kind of movement.
Yeah. I don't think we know where things are going. Things are moving so quickly now. I mean, artificial intelligence, it's everywhere now, but before 2010, it was all in academia.
Exactly.
And now we've got things like, the generative AI and ChatGPT. And now people are giving you generative AI on a memory stick that you can plug into the side of your computer. So those generative AI that you use for generating images, you can get the whole thing on a stick.
Yeah, it's correct.
It's incredible. So goodness only knows where we're going to go in the future.
Yeah, it's true.
Well, thank you so much, Jamie. That's wonderful.
Max.
Very much appreciated.
Okay, thank you. Bye.
Bye. Okay, everyone. So we've had a fantastic day of talks. There's been some really great presentations.